My name is Kobe Farwick, and this is the beta demo of the active Sidestick for spring quarter 2017. So for the beta demo, I really want to focus more on the software integration side, since the previous demo, the alpha demo, I had shown more of the hardware, what it looks like, and how it's all working. So the basic concept here is there's communication between Prepare 3D, which is a simulator hosted on a PC, and Arduino and a Teensyduino. So the Arduino will receive flight variables from Prepare 3D using a program that I wrote in C++. Then it's also capable of sending serial debugging data back to the PC over USB. The Arduino will also send joystick position data to the Teensyduino, which will allow the Teensyduino to act as a human interface device to the PC, basically a joystick input, so we can complete the loop in the simulation. I wanted to quickly demonstrate how the P3Duino program is going to interface with Prepare 3D and Arduino. So on the left is Prepare 3D. I am currently at San Luis Obispo Airport, and you can see there's photoreal scenery here that I'm actually working on myself to make things a little bit more realistic when this project goes on display at the expo in June. So to get things started, we have to select which port our Arduino is on, and you can see here it's on COM port 3. This is shown up in the list of available ports. So I'll go ahead and select COM port 3. First, I have to get connected to Prepare 3D, so I will establish that connection, and you can see it's now reading out the altitude data, airspeed, and barometer. Airspeed 0 because we're not moving at this point, but I will show you that changing here in a minute. So with that established, we can now connect to the Arduino, and at this point, the program is packaging up this data and sending it over the USB port or serial port to the Arduino. So if I go ahead and pause the simulation here, you'll see these variables begin to change as they're retrieved from the flight simulator. So you can see they're changing, altitude change, airspeed's up now, and the barometer is not going to change because that's just the standard barometric pressure. And all of this is being sent to the Arduino in the background. I also wanted to show my Simulink model, which allows me to vary the force gradient constant and the applied force to the system, and see how the system will react, or should react in theory. So the force gradient constant is basically a variable that defines how hard it is to move the stick at any time. So if you're flying very fast, you're going to have a high force gradient constant, which is going to translate to more force required to move the stick. And then if you're flying slow, then it's going to be easier to move the stick, and you're going to have a lower force gradient constant, probably in 0.1 range. The standard force gradient constant is 0.24 for this application. There's a discrete sine wave for the force input, or a custom signal for the force input if I want to test how it would react to fast inputs from the pilot or abnormal inputs. The rest of this is just implementing an equation that translates the force to commanded servo position in degrees. So over here, I have that equation displayed here. As I said, it uses the force in ounce inches and the force gradient constant, which I'm calling kg. So it ends up outputting a position or displacement in degrees. So this value is fed into the PID controller over here. We have a discrete PID controller, which is set up for about 86 milliseconds interval. which is defined by the Arduino. I timed how fast it could go through the force feedback algorithm and set that as the interval for this controller. Then I also have a transfer function for the servo, which I developed by looking at the data sheet for the servo that I'm using and looking at how fast it can respond to a step input. So just came up with a simple first order model for that. Then its output to a couple of scopes here. So in this case, I'm using the discrete sinusoidal input for the force. It's going from 0 to 300 ounce inches. And then you can see the output from that equation I just discussed is right here. It's the commanded position. So this is the desired position based on the force input. And the force gradient constant here is also varying. So it goes up to 0.75 range here. So it'll be a lot harder to move the stick, as I said. And you can see that over here in the servo position, which this is the actual output from the servo after the transfer function right here. So when it's very high, the force gradient constant, there's less displacement by the servo. And then when the constant drops even lower, below 0.2, this typical value, you can see that the amount of displacement spikes significantly for the same amount of force. I also wanted to demonstrate the full integration of the Sidestick and Prepare 3D. So you can see that I am actually controlling the simulator using the Sidestick.